Well, here's the offending fridge. So I say 330 quid, still sold by Currys, I think, and a number of other outlets. It's a nice wooden frame, stainless steel frontage, designed to go into a built-in unit, I think, so it's got fans inside to force cooling of the compressor. But what this one is doing is, it's the lights come on, the temperature gauge, you can see it in there, CDA is working. It's quite cold out here today, it's a very fresh day, but the compressor's not running. You can't hear the whirring noise that you normally hear from the back of the fridge from the compressor, which is located down in there. Okay. So the story is that they couldn't get it replaced under warranty because they didn't take extended warranty, because it was installed by a kitchen supplier who fitted it into a friend's kitchen. And yeah, so they couldn't get it under warranty, so they called a refrigeration engineer and said, he came in, looked at it and said, sorry, can't fix it, it's probably an electrical fault. So it was scrapped and they were going to throw it away. So here it is, and I've got the fridge. You can see it's got, as with most refrigerators, it's usually got the circuit diagram on the back, which is a help. I think the electronics are working. I think it's more to do something to do with the compressor, because I can hear it buzzing, but it's not running. I can't hear the piston or the vibration going up and down, and it's just not getting cold. So let's I'll take this bottom off and then we'll have a look and see if we can fix the thing or not. And if you remove these 4 screws from the base, from here in this plate, 1, 2, 3, 4, the compressor will pull forward slightly. Okay, but don't pull it too far, because there are pipes around here and they're pressurized, and you don't want to crack them or your gas will all leak out. And you can see these have got the latest cyclopentane C5H10 inflammable, like the old fridges that used to use ammonia were a fire risk. Well, if all your gas leaked out, this stuff is pretty flammable, so that would not be good. Anyway, going back to the actual compressor. So as I say, on the side of the compressor is this box, plastic box mounted on the side. And you pull the plastic box off. So on the side of the compressor, after you remove that box, is this small black module with a positive temperature coefficient thermistor inside. And what it does is, it's got one connection where it goes straight through to the main winding, the power winding of the motor, but there's a starter winding also, and the starter winding needs some current at startup to make the motor, well, to give it torque at low RPM, i.e. when it's stopped, and also to make it go the right way. So if your unit is just sitting there buzzing and not doing anything, it could be that this PTC is blown up. We'll take this one off and have a look and just get it underneath the light and in the office, and you can see. But its job is to connect the starter winding to the mains momentarily, and as the thermistor heats up with the current flowing in the winding, thermistor gets hot, and then the current, the resistance increases, of course, because it's positive temperature coefficient. And yeah, it turns off the current. It doesn't turn it off completely, but it turns it down to a small idle state of the current when the thermistor is hot. Okay, so that's what that is. It's the starter module. I'm going to whip that off. It just levers off. It pushes on some pins on the back. Obviously you take the wires off to make sure they go on the right way, but we'll have a look at this in the office and see what's going wrong with it. Here's the little black starter module. I've taken it off. It just pulls off. It pushes onto 2 pins on the actual motor, the fridge compressor motor. Usually it's got 2. It's got an M here for motor, and this is the start winding. So that connection on the back goes straight through to the motor main power feed, and this one goes via the thermistor, the PTC thermistor inside, to the starter winding. That's why it's got an S on it. So I'll just open this up. Actually, I confess I had this open earlier in the garden, and a whole lot of bits and pieces fell out of it. The thing had just shattered inside the actual thermistor. So, but I've got a bit left I can show you. You have to use your imagination. But there's not very little inside this. I'll get it open. There you go. So lid's off. You got that's all that's left of the disc. The rest of it went on the grass, I'm afraid. And so it's just between these 2 connections is this thermistor. And if I pull it out, you can see it's a quadrant I've got left, about a quarter of it. But it was a round disc. It's a totally round disc to start with, before it all fell over the garden. And it's just a ceramic disc with a special conductive material that goes up in an oxide, I think, goes up in resistance as the temperature rises, and on each side it's plated with a silver contact to make contact with the whole area of the disc. Very, very brittle. I tried to heat these up with a blow lamp before and they just explode. The thermal shock of the flame on them just caused them to disintegrate. There's some kind of sintered metal. They look almost metallic, don't they? Anyway, so that's what's inside. That's the thermistor disc. And so, yeah, if your motor is buzzing and not turning, it's worth investing in one of these because it could save you some money. The only thing I should mention as well is that they come in different varieties. They come with 1 and 2 contacts, and they come in different resistances. Usually this is a 15 ohm one because it's got 15L on it, and it's a QP2-15L. So make sure you buy the right resistance ones for your motor, because obviously the bigger motors will have a lower resistance one. And as you power it up, the current that flows through to the starter winding heats up this disc of material. Material goes higher and higher resistance until effectively it goes open circuit, and then it just remains hot by a residual current going through it. So it's a very, very cheap way of energizing the starter winding when you first turn the power on and the motor is cold. Not so sure if you turn it off quickly and turn it back on, the motor would stop, and I'm guessing this would have to cool down before it would start again. Not sure, but a proper piece of kit would have a relay controlled by the main controller on the board, or by another control electronics, which would just momentarily close and then ping, the relay contacts would be open. Because this does take some power when it's just running the fridge, because it obviously has to stay hot. Therefore, you know, 500-600 milliwatts might be, or up to a watt might be dissipated inside when the motor is on, even though there won't be a lot of current flowing in it because it will be high resistance. So that's what was inside there. Well, I put the starter module on, put it back together, and it's working. Look, we've gone down to 41 degrees. It's been on for about an hour, so it's chilling out my wine and beer for tonight's tea. Really expensive piece of kit, really, when you think about it. I mean, it's 350 quid. You can get a full washing machine, a good one for that, or best part of a really nice fridge freezer. And this is just a piddly little motor which you might find in an air conditioner, a couple of fan motors, a bit of woodwork, and an enclosure. Expensive, high margin object. You'd think they'd take more care and use a more reliable Samsung compressor rather than a Chinese one with, you know, it's just not good enough, is it? 18 months and it's in the bin. Really? Honestly. Anyway, there it is, and it's working, so job done. Hope you found that interesting. If you can, leave me, well, subscribe down there if you're not subscribed. If you are, thank you very much, and just leave me a like, because I like likes. Thanks.